recording. Okay? Hopefully you guys are watching it if you get confused. It's sent to you, your school email and your personal email. Or you can get, I tried your personal email, it bounced back.
I know, there's something wrong with my phone. They trying to get me to, they wanted me to pay for more storage through Google One, but when I done it before, they robbed me of money. So
I don't blame you.
I just,
But you have my YouTube channel.
I'm looking at your YouTube channel.
Okay. You've been offered a job at Long's Bakery. Your friends ask you, how much money will you earn by the end of the school year? How might you answer this? So you get a new job, you get a certain amount of money per hour, and it's asking you, how would you figure out how much money you would probably make at the end of the school year?
We gotta figure out how much you were gonna work,
You'd have to know how many hours.
and then how shifts between that point and the point in which you go back to school.
Correct. So the total hours you would work in that time frame, right? You're taking a road trip over summer vacation and will start driving west when your school goes on break in June. Your uncle in St. Louis, Missouri asks, when will you get here? And your answer says, well, it depends. It all depends on what? What might interfere with your travel time? Traffic. Yep. If you get a flat tire, how many times you have to go to the bathroom? And make stops. Yeah, because if you have a little kid with you, you got to make more stop breaks. Or if you have my husband with you. Okay. The outcomes of these two events above will vary because the factors that affect them vary. Relationships in which outcomes depends on certain inputs are called functions. So let's go back to that. Let's go back to that law. At the bakery, right? If you get paid per hour, you can pretty much guess what your pay is going to be each week. Has anybody here ever been a waitress? Okay. Do you know from week to week what your pay is going to be?
No,
No. Why not?
because it depends on how much people.
We get paid on tips.
Correct. So the Long's Bakery is one that we would call a function because you can predict it based on your input.
Okay.
But waitressing jobs, that would not be a function. And I'm going to explain the definition of a function, but at least you have something to reference in your brain now. You know, somebody who makes the same amount of money per hour, that's a function. If it's all over the place, then it's not a function. Examples, you try. State which one of these input X and which one's an output Y. My test score and how much you study. So what would be an input versus what would be an output, do you think? Yep, exactly. Because how much time you put into it affects the outcome. Okay, what about example B? The amount deposited in the bank and the interest earned. So what would be the input and what would be the output?
The input will be the money you're putting into it, and the output will be the interest you're earning.
Correct, because the bank gives you your interest based upon how much money you're letting it be in. If I only put $100 in, I'm not going to make a whole lot of interest in a month, right? But if I put $10,000 in, I'll probably make more interest. Where you live and your zip code, which one's the input and which one's the output? Which one determines which? Yeah, I think your address would be your input, and then you pop out your out. Because we could live in the same zip code, but not live anywhere near each other, right? Okay. In algebra, the special relationship between two sets of circumstances is called a function. Functional relationships are dependent relationships, meaning the output, the result, depends on the input. Your salary depends on the number of hours you work. Hours is your input, output is your salary, right? We're on slide 7 right now, if you're trying to find. This should be easier to find. We're on the one with the function machine. Okay, the input of a function is called the independent variable and usually represented by x. And Mary, you mentioned this before when we were talking about those word problems. You're like, which one is x? And I gave you an answer. I said, because I knew we were coming to this one, but I said, which one is always x? You remember? No, that'd be slope. Time. Time is always your input because time doesn't change, right? It's going to be an hour. An hour from now, it's going to be an hour. Even if there's an earthquake, it's still going to have that same time frame of an hour, right? Now, outputs based on time, that would be different. Like, well, of course, like if you work so many money, so you get so much money per hour, your output would be your total pay, right? That'd be output based on time. It could also be as how long you are in the car and how far you go, right? The how far you go depends on how long you're driving the car for. Does that make sense? So your input is your independent variable, but the output is called a dependent variable. It's based upon the input. Okay, does that make sense so far? Can you think of a real world example of a function? What would be input and what would be output? No, she's going to input some cabbage and some sausage, and what's she going to output? She's going to have either a soup or a dinner, right? So her inputs would be what she's putting in. The output would be her final result.
My input is 5 oil pastels, and the output is
There you go. Okay, so you get these nice colored pastels, and from there you can have an output. Yes, agreed. So your input is what you're starting with, and then it creates something to give you your output. Make sense? Okay. Functions can be represented in many ways. We just talked about different language and context. Talked about soup. We talked about art. Talked about pay. Talked about miles per hour. We can have equations. We worked with 3 equations recently. Y equals mx plus b, which is slope-intercept form. We worked with standard form, where x and y are on the same side of the equal sign. And then we had point-slope form, where we had y minus y1 equals m parentheses x minus x1, right? We have ordered pairs. An ordered pair is your x and your y. Have we graphed x and y's before? Yeah. Tables. Tables would mean you have like an XY chart where you have all the X's on one side and then the outputs from those X's on the other side. That'd be your tables. And then, of course, we have graphs, which you just got tested on. Functional relationships are dependent relationships. The output depends on the input. A function is a two-variable relationship in which one variable depends on the other. A function can be described by using a graph, an equation, a sentence, meaning language, ordered pairs, or a table of values. Relation. A set of ordered pairs, inputs and outputs. These ordered pairs are often written with brackets. For example, the ordered pairs of age versus height are shown below in the relation. So I don't know if they're talking about centimeters or inches. I'm going to assume inches. So at 15, somebody may be 65 inches. At 21, 70 inches. At 18, 73 inches. At age 16, 62 inches. They may be just random people. I could do that in this room right now. I could say, how old are you? And what is your height? I think Musa has us beat on height. I think he's the tallest one in the room. Right? Yes. Did you have a question, Gemma? No? Okay. But there's a definition of a function that has to happen between the inputs and the outputs. I had his test. What did I do with the test? I just had the test. I was handing them all out. Where? Oh, sorry. Okay. A relation is a function provided there's only one output for each input. It is not a function if one input has more than one output. So at the waitress, you could work 1 hour on a Saturday and make a lot of money if it's Saturday evening. You could work an hour on a Monday afternoon and make diddly squat, right? Exactly. That's not a function because you had two different outputs for the same input. 1 hour, lots of money. 1 hour, little bit of money, not a function. Got it? Okay. So function is a special relationship between two sets of numbers or circumstances. A relation that assigns a unique output for value for every input. Called a mapping diagram. Has anybody ever seen these before? Okay. Ray's seen them. Well, have you seen a mapping diagram before? No? The first time? Have you ever seen one of those? You have. Okay. Have you, Hannah? Okay, I'm just trying to get a feel. Okay. First of all, domain is another name for X values. Okay? So all of these would be considered X values. -1, 0, 1, 2, 3. Another name for domain are what? X values. You may want to write that on your paper and star that. You need to know the difference between domain and range. Well, if domain are X values, what do you think range is? Range are Y values. So as long as the X values are all going only to one place, it's considered a function. But if I get an X that go to two different Y's, then I have a problem. So this -1 is going to 5, right? And it's only going to 5 because there's only one arrow coming from there. 0 is going to 3. 1 is also going to 5. That's okay, because for every input, we still only have one output. It's the x's that if they repeat or have two different inputs, that make it not a function. 2 to 11, 3 to 21. Okay, so this we would say yes is a function. Okay, what are domains? Domains are x values. What are range? Y values. Now, ooh, that's hard to read. Does this mapping diagram represent a function? So I got 0 going to what? 0 is going to -2, and 0 is going to 1. Is this a function?
No.
No, it's not a function. Because this x is going to two different places. Did you get one of these? I put them right on the corner right there. Right on the corner. You got a pencil? Okay. So this first one, we'd say if I asked you, is this a function? You'd all say no. And the reason is because at 0, it's going to two different places. The other ones are okay, but it's at 0 that made it not a function. Okay, let's look at this one. Identify the domain and range, and then tell if the relation is a function. So, input is also called domain, which is also called what? X values. When you are listing your values, you always list them from least to greatest, and you don't repeat, okay? So if you see it twice in a list, you would just write it once. So I have -3, 1, 3, and 4. That's the domain, because those are my inputs or my x values. They all three of those mean the same thing. Domain, input, x, they're all three the same thing. And they're all considered, there's actually a fourth word for that, independent variable. Over here, we have an output, 3, 1, -2. But do you see how they wrote it? You have to write them in order, from least to greatest. So, is this a function or not a function?
Yes.
Yes, because -3 goes to 3, 1 goes to 1, 3 goes to 1. That's still okay. It's if this side goes to two different ones. And 4 goes to -2. So we'd say yes. Why? I'm going to type it because I have bad handwriting. But I better change the color because it's on this gray. I'm going to have to change the background of that PowerPoint. Put red. I thought I pressed red. That's red. For every input, there is one output. That's why. I'm going to make this bigger, just in case somebody needs to see it better. I think I can make it bigger, yeah. Right? For every input, there is only one output. We good?
It's Dawn.
Hmm?
You also say, the reason it's a function is because the inputs don't repeat.
Yep. I said that earlier. I usually say that when I get
So
to.
it's in Adam's class.
Yeah.
Like, oh, I know how to do
Yeah.
this.
Yeah, usually I do that one when your inputs won't repeat, but usually when I see relation, when it's going this way, since this
That's
is
the word he couldn't remember.
what?
Relation.
Relation.
Correspond, relationship, something, because I can't remember what it is.
Okay.
Relationship.
Oh, it says here, identify the domain and range and tell if the relation is a function. So is this one a function from the picture? Yes or no?
No,
No. And where is it not a function?
one.
Yep, at the 1. This is no. And why? Because one went, or is mapped to, I guess I should, that is better, is mapped to. Okay, it's no because number 1 is mapped to 2 outputs. One went to -2 and one went to 1. And then to list the domain and range, you list them from least to greatest, and you won't ever repeat a number in this list, okay? Notice that they have brackets. My brackets always look weird. I try. I can't make my brackets look nice. Almost looks like a face on the side portrait. Okay, this is usually where I say the inputs won't repeat.
I think his is out of order, because he did this one first and then he did the arrows,
Oh, he must have used a different
Yeah.
PowerPoint. That's okay.
because he was missing some slides too. So.
Yeah, we're just doing, usually we do the same notes, we just ran some too.
Yeah.
But we're doing the same topic. We're trying to stay on the same page. Okay. Is the following set of ordered pairs a function? Why or why not? So, you all know I taught GED classes, and I know that's a dirty word here, but I did teach GED classes. And I used to tell my students this is the easiest question to get right on the math part on the GED. And they always had this one on there because you're not doing any math. You're just seeing if all the x's are different. As long as all the x's are different, you're in good shape. But if you have an x that is going to 2 different ones, or basically your x is shown twice or 3 times, then it's not a function. Do I care about the y's? Everybody's saying no. Okay, I'm going to say that again. Do I care about the y's?
No.
No. What do I care about? X's. So I'm going to underline the x's. Here's my x's, which are always the first one, right? Is there at any point that I have the same x's?
Yes.
Yeah, right here and right here. So is this a function?
No.
No, this is not a function. Because, because the 7 goes to 2 different, you could say output, you could say range, say y values, 2 different outputs. Okay, now it didn't ask it to do it here, but on a quiz, this is where I would ask it. I wouldn't ask it from a mapping diagram because they already separated out for you. If I want to list the domains, what was the domains again?
7.
The domains were the x values. You're fine. You're more than fine. I like seeing you in class. Okay, so we want to go from the least to greatest, and we are not going to repeat a number. So what's the smallest x value? The ones that are underlined. 0. Everybody agrees 0 is the smallest one? Okay, what's the next one? 1. There's no 2, but I do have a 3, and I have 4, and then it goes 7. I only put 1 7 even though there's 2 of them. That's the correct notation. And I'm going to list the ranges. And when we get negatives, it gets a little bit harder.
Negative 7.
-7. The more negative are, remember that's the smaller because you're in debt, you owe more money. Or -4, 0, 1, 3, and 7. There. And that'd be your range. So domain X values, range Y values, you write them from least to greatest, and you don't repeat. It is not a function because there were two inputs going to, one input going to two outputs. Okay, so we can determine if a relation is a function by using a few methods. Check that no domain X values are repeated. Analyze the graph of the relation, the vertical line test. Use a mapping diagram. So, we haven't talked about the vertical line test. Before we talk about it, vertical. What does that mean? What direction is vertical? Up and down or left to right? Up and down. So what we're doing is we're going to be looking straight up and down at a graph. And as long as it only intersects at one point straight up and down, then it's a function. But if I pass through two or more straight up and down, right under each other, then it's not a function. So pass or fail the vertical, and this is just saying what I said. Okay? Let's try one. Okay, here's so think about having a ruler and passing it through there or looking straight up and down. Use the vertical line test visually to check to see if this relation is a function. Is this one a function?
No.
No, and the reason is because right here, ooh, I don't like that one because it's not. Can I make these thicker?
One.
I know, yeah, I'm just trying to make this line a little thick. Oh, it's up here. Oh, there we go. Because right here, there we go. Right here, it's kind of too thick. But right there, you could see that it didn't pass the vertical line test, right? Plus it says ones. We had two ones. So, and that's why it's called the vertical line test, is because if it's right above each other or below each other, that means the x's would be the same. So that's why it would not be a function. So this one, what would I write? Is it a function or not a function?
No.
Yeah, this is not a function. We're having fun with functions, everyone.
Yay.
Yeah, yes, yay. I'm gonna try to make that bigger. Okay, next one. Okay, what about this one? If I'm going straight up and down, is this a function?
Yes.
Yeah, this one's a function. So this one, I would say, if I can bold, I can't bold. This one we'd say is a function because it passes the vertical line test. Have I lost anybody yet?
Not yet.
Oh, yeah. I'm gonna make a sharp turn. No, I'm not.
There's still time.
I try not to. Okay. So this graph is called a parabola. When you get to Algebra 1B, we'll graph these more. I don't think we get to graphing parabolas in 1A, but you'll get to that in 1B. I'm going to look straight up and down, right? I'm looking straight up and down. Is there any time I go through this more than once? No, this is a function. So now if it was sideways, then it would not, because then it would keep going. But this is a function. So I'm going to say what? I'm going to say this is a function. Because I never look up and down and pass through more than one place. So all my x's are different, right? Oh, there's the sideways one. Is this a function? No, because if I go straight up and down, there's 2 points here. Right here and right here, that the x values would be the same. The y values would be different. So we would say what for this one? Not a function. Not a function. This one's no fun. I like being silly. Okay, I didn't get a laugh out of Mr. Brandon over there. Okay, so I'm gonna go straight up and down. Again, is this a function or not a function? This is not. So this would be not a function. Because if I draw a line, it doesn't pass the vertical line test. Right? It doesn't pass. Because I have 2 different spots. Okay. What about this one? Is this one a function?
Yes.
Yeah, this one's a function. So this one you can just circle the big yes. Because I'm looking up and down. Is there any time I pass through it twice? Boop, boop. No. It's good. What about this one?
Yes.
Yeah, this one is. This is still a yes. What about this one?
No.
No. Because if I draw straight up and down here, actually it goes 3 places. Here, here, and here. That means your x's would. What about this one?
No.
No. Go ahead and circle no for this one. This one's a yes. 'Cause if I go up and down, I don't pass it through more than one place. This one a function?
No.
Definitely not. All the x's are the same. Oh, I can't make a circle. There, now I can. What about this one? That's another no. Because you have these vertical lines here. All these points are right up and down. And all of these are right up and down. So that's not a function. What about this?
Yes.
That one's a yes. Takeaways. A relation is a set of ordered points. All functions are relations. Oh, I'm just going over. It's all in there. We have to save on paper, and if I had an extra slide, it would have bumped it off to a different paper, which would mean over 15 sheets of paper. And since we were asked to save on paper, that's why. And that's why you're getting some things that are a little bit littler. It's just they want us to save money. So for a relation to be a function, all your x's have to be different. No repeating x's, right? We good? Okay, well then I'm going to go ahead and give you your